Second one is the rope brake dynamometer. I will give one example. Suppose I am having a pulley. I am having a pulley, and on this pulley there is suppose one rope. But that rope which I am using, that particular rope, if I try to wound, I will show. If I try to wound in this particular manner and then apply weight, and this one is rotating one. If I go on increasing the weight, what is going to happen? No doubt, if suppose my pulley is rotating in this direction, in this in opposite direction, and the force exerted is in this direction, definitely there will be a restriction created. There will be restriction or a brake created. That's why it has been special rope brake. So it consists of one, two, or large number of ropes. Here it has shown also. This is the one rope. This is the another rope. This is one of the cooling input that has been provided. So these are the ropes. Here is your dead weight that has been applied. Actually, this rope has been wounded on this pulley, and then it is connected to the weight. This is nothing but the spring balance. So how much energy or the power which is required, that is supposed to be highlighted in that aspect. Okay. So it consists of multiple ropes wounded around the fly pulley. Okay. So fly pulley is you have already seen that this is nothing but your fly pulley. It is rotating, and here we people are trying to apply the input. Now, so or a rim of a pulley fixed rigidly to the shaft of the engine. So upper end is kept in the position while the lower end of the rope is kept in the position applying dead weight. So this dead weight is playing the role that to stop the rotation. So how much energy is required, and your spring balance is trying to represent the resultant output. Resultant output. Okay. So in order to avoid the splitting of the rope over the fly pulley, actually if suppose that groove of the pulley is smaller one, at that time what is going to happen? It is going to move away from the groove. So here you people can provide a wooden block so as to keep the rope inside the circumstances of the fly pulley. Now for the operation of the brake, the engine is made to run at a constant speed, and the friction torque due to the rope and weight, as we go on increasing, the weight, this rope will become tighter one. So it is creating the torque friction. Okay, must be equal to the torque being transmitted to the engine. So here W is your weight at the end of row, S is your spring, N is the engine speed, revolution per minute, D is the diameter of the brake wheel, capital D, and small d is the diameter of the rope, and D plus D is effective diameter of brake wheel. Okay, so this is the rope brake dynamometer concept, and it is having the advantage that it is low cost, that is cheap, and it is having the easy construction. But it is also having disadvantage that this is not an accurate one or precise one due to change in friction coefficient of the rope with temperature. Because what happens, the rope may get elongate or due to the tension and all that things. What type of rope we people are using, whether we are using nylon rope or some other rope, at that time that problem may arise due to the variation in the temperature, and this can be used for the absorption diameter most common. Driving dynamometer or epicyclic dynamometer, train dynamometer. So this dynamometer measures a power or a torque, and as well as provide energy to operate the device to test. So this is the schematic representation that consists of a pinion that is connecting your lever and between the pulley, rotating pulley. We are having lever. Across the lever, there are two weights. One is at your right hand side and another one is at this particular one. Here is the pulley. Here are spur gear. These are nothing but the diameter. Here is the force. This is nothing but angular gear. Okay. And this is your lever. Okay. So over here, the concept is very simple, that a epicyclic train of a gear, that is super gear, this super gear is keyed to the engine shaft. It is connected to the engine shaft, and that engine as rotates in a anti-clockwise direction, opposite direction. Okay. The angular gear is also connected to a driving shaft. Angular super gear and angular gear also connected to the driving shaft, and it is rotated in clockwise direction. So what is going to happen in this aspect? One is rotating in this particular direction and another one is rotating in this particular direction. In opposite direction, both are rotating. Okay, so super and angular gears. So the pinion, that pinion which I have shown to you, or a intermediate gear. Pinion is nothing but intermediate gear mesh with the both the super and angular gear. So pinion revolves freely on the lever. That will rotate freely on the this one, on the on this particular lever. Okay. So a weight W is placed at a smaller end. I have shown both the weights of the lever in order to keep it in a position to maintain the balance condition. Actually, weights are used in both the sides. So what is going to happen? That tangential effort P, tangential across what pinion, effort P exerted by the super gear. If you try to recall the previous case, that is uh, the previous mean, here P at the pinion, P at the pinion, this part. So what is going to happen to this particular aspect due to this one? That tangential effort P exerted by the super gear on the pinion, and the tangential reaction of the angular gear on the pinion, they are equal to each. So for equilibrium of the lever, that takes a moments about the fulcrum yap. Moments about the fulcrum yap, that has been shown below. So 2P into A is equal to W into L, or P is equal to W multiplied by L divided by 2A. All the specification I have specified at the upper end. So if you try to see over here, these are the specification that has been provided over here. W is weight, length, power. Okay. R is your pitch circle radius of the surf gear in meters, and N is the speed of the engine shaft in RPM. No doubt, torque which is supposed to be transmitted is P is equal to P into R. Okay. So here the computation of the power is again given by P is equal to torque multiplied by 2 pi N divided by 60, or here T is equal to your PR. So this has been replaced. So here it is 60. Okay. So make that particular corrections. Hope so you people have understood this concept.